Right, so the motion, uh, this motion is completely a simple harmonic. This is not partly simple harmonic like in the previous example. You can see that when the particle passes this point O, this part becomes under tension and this part becomes slack, right? So the equation is the same, you get the same characteristic equation, and it's the same. So the particle will always be moving under simple harmonic motion, right? In the previous case, you know that when it passes O, the string becomes slack because there were no strings attached to the particle on the right hand side like this. Now for part B, if U is given at O, suppose the particle is at rest, right? Then you are giving the particle an impulse. So due to this impulse, this will acquire a velocity at the point O. Suppose that velocity is U. If this is U is given at O, that means at x equals 0, the velocity is U. Find the amplitude, period, and then maximum U that can be applied. So what is the maximum then? That means maximum U, uh, maximum U that can be applied such that A is less than A. Let's try it. Otherwise, this would not be meaningful. Right, so the first thing, if U is given at A, find the amplitude. So what is the equation we use? We use V equals V squared equals omega squared A squared minus x squared. Right. So you had to find the amplitude. So we use this equation. Now U is given. So U squared omega squared is what? G over L. Then A squared minus what is x. So the velocity is given at x equals 0. This is 0. Therefore, A would be U times square root of L divided by G. Square root of L divided by G. Right. Okay, so then the period, will period differ from the first part A? So the period is calculated by 2 pi over omega. Now you can see that even a velocity is given to the particle. So nothing will happen to this characteristic equation. Characteristic equation is the same, right? So you can see that characteristic equation is not influenced by any velocity is given. So we just look at a general point and we write down the characteristic equation. That's it. So the period will not change. It's the same period you get. Then the maximum U that can be applied such that A is less than L. So what does that mean? That means you're gonna restrict A to less than L, less than no equal to L. Let's say that means whatever the velocity that is given to the particle must not hit these boundaries. So let's say not equal. It must not hit the boundaries here. So therefore, A should be less than L. This means U root L over G is less than L. Therefore, U should be less than root L over G. U should be less than root L over G. Right. So this is the answer to this part. Right. So let's meet again with the final part of this